On this problem, they're asking us whether or not the vector field is conservative, but they don't give us the vector field formula. They give us a picture of the vector field. So we can't just use our conservative field test. But what we're going to do is we're going to use these facts that we know about a conservative vector field. You can use either one. If a vector field is conservative, the work around every closed path is 0. So if you look at this and you think about a closed path, like let me just draw a random closed path here. Is the work about that 0? In this case, we're going with the flow the whole time. When you go with the flow, the work is positive. Going with the flow the whole time, then the work would have to be positive for that closed path. So it's not 0. So we found a single path about which the work clearly isn't 0. So that means this vector field cannot be conservative. Whereas this one, if we were to draw a closed path, let me just draw a random closed path. What might the work be around this? So here we're sort of going with the flow, so we're accumulating positive work. Let me draw it here. So positive work here, and then we're going against the flow, so we're accumulating some negative work, still going against the flow. Right about here we're going perpendicular to the flow, that's 0. And then we start going with the flow again. With the flow, perpendicular to the flow, that's 0. Now we're going against the flow. So when we're going against the flow, we get negative work, and when we're going with the flow, we get positive work. And we can't tell for sure, but it is possible that the negatives and the positives cancel each other out, and that work is 0. Now that doesn't prove that it's conservative, because we'd have to show for sure that it's 0, and we'd have to show that for every single closed path we draw anywhere, that the work is 0. So we can't really prove that it's conservative this way, but we can be convinced that it's not conservative if we can find a closed path which clearly the work is not 0. So this is not conservative. This could be. How about the second fact? How would we use that? Again, you can use either fact. You don't have to use both. For the second fact, if I choose any random point A and say B, if the vector field is conservative, then regardless of the path I take, the work should be the same. So what I want to do is look at two paths, any two paths, and see whether or not I think the work would be the same. From A to B here, I'm going with the flow the whole time, so clearly here the work is positive. But on the green path, I'm going against the flow the whole time, so clearly that work is negative. So the work is different on different paths. That means the vector field is not conservative. If it's conservative, I should get the same no matter what path I take. Different paths, clearly different values, this vector field is not conservative. Whereas over here, any 2 points, take any path. Okay, what do I think about that one? I'm going against the flow, now perpendicular to the flow, now kind of with the flow. So I'm not sure what that is. That might be around 0. Not really sure. Go a different path. Let's go some kind of crazy path here. The work here, I'm going against, so negative, perpendicular, so 0, with, so positive. So I've got some negative and some positive and some negative. So I'm not sure what it is. I'm going to write 0, but the key here is not 0. Let me just put a number. So this might be 1/2, and this might be, I don't know, 1/4, or negative 1/4, I don't know. The point is I can't clearly tell that they're the same or different. I can't clearly tell they're different. So I can't rule out conservative. It could be conservative. These could be the same amounts. Whereas here, clearly they're not because I can see that one is clearly positive and one is clearly negative. So this could be conservative because I can't know for sure that I get different values on different paths. This one is not conservative.